Hi, welcome to a new video. In today's session, we're going to talk about Spark, and to be more specific, we will go over on how to use Spark for machine learning. So, in our previous lecture, we discussed a little bit of Spark, and you already know it's a framework that will help you to perform some analytics, SQL, and machine learning when you're facing a scenario where you have big data and your data is like split in different uh, nodes in a cluster, so it's not the typical framework for a single machine that where you have pandas and some traditional data science libraries. So having said that, we're using PySpark because this is for Python. And in PySpark, you can access the ML module, which is the same as in Spark, is the machine learning. In other versions, they used to have the ML lib, like machine learning library. That package is being deprecated, so please focus mainly in the ML module, which is very similar to traditional libraries. Okay, so from the PySpark machine learning, we're gonna use the linear regression, different regressions, logistics regression for classification and for clustering. In this video, I will show you one example for regression, one for classification, and one for clustering. This is really important, the vector assembler. And this is like the main difference when you are using Spark compared to previous libraries. This is the way in which you need your data. We're going to change the shape a little bit. So typically we will have two columns or a single column, regardless the number of features in your problem. Okay, so first thing, we need to initialize a Spark session. It's important to mention that I'm using Colab here, even though I'm working on VS Code. My kernel is from Colab. You can read here Colab. I'm using the Colab extension. I mentioned that in the previous video. Okay, so let's just understand the data format. So typically you will have like a matrix for the X variables, right? You have like the first X1, X2 up to Xk, and each X is a independent column, right? And there is only a single column for the Y variable. That's the typical array in which you will have your data, in previous problems. Now, in the case of Spark, when you are gonna create some models, you need to put your data in only up to two columns. So if supervised learning, so you will have one column for the features and one column for the dependent variable for Y. If it's unsupervised clustering, you will have a single column, just the features column. And in each row, there is a vector with the feature values for that specific observation. So that's the main change, and you will see it in our three examples, right? Using the vector assembler. Okay, in our first problem, regression example, I'm pretty sure you have seen this problem before. It's about predicting the median house value in California, and we have different variables, right? So this is our typical. This is how a typical data frame will look. Yeah, there is nothing weird. Now we're gonna convert that to our Spark data frame, right? Because we need that format so we can use these tools. It will look a little bit different, but again, at this point, it's the same. It has like different columns for each variable, and our target is price. Now, when we apply the vector assembler, so it's gonna put our features, as I mentioned before, in a single vector per observation, right? So that's the main change. Now we have only two columns. So this is required for the Spark ML because in this way it optimizes the parallel processing, and it also is faster for this package to access to data that is stored in different machines. Okay, so once we have our data in this format, then the rest it looks very similar to what you have done in the past. So you split your data. Right here we have 80% and 20%, right, for training and testing. And you can start creating your models. So again, if you look at this linear regression, it looks very similar to what you have done in the past with scikit-learn. Yeah, there are no changes really. It's just the filter and the price. You train your model, you feed your data, and then we can analyze the data. We can, like there is a evaluator, regression evaluator, where you can use different metrics. So the RMSE, that's one metric, or also the R squared. So you can get both. So in this specific example, let's see the performance. The R squared is low, 0.52, and the RMSE it's 0.79. So again, you can test different algorithms here for regression. I'm not discussing the, like how to improve it. You can, like perform some hyperparameter tuning. You can compare other, other algorithms. So in general, for regression, there are other options. So you can use like random forest. You can use, there are some, here you have the list, linear regression, decision tree regression, random forest. There are some gradient boosting if you want. So there are, alternatives to be able to perform the regression model. Okay, let's go over now the classification. The structure is similar. So let me show it to you. So the second example, this is from scikit-learn. Remember to predict whether a tumor is benign or malignant using like 30 different variables. So again, in Spark ML, there are different classification algorithms: the logistic regression, decision trees, random forest, right? Even there is some like neural networks here. We have the MLP, multi-layer perceptron classifier, which is a paper algorithm too. All right, so this is our original data frame. Now we convert it to Spark, and then with the assembler, remember, we need to put the 30 variables, right, per observation. I'm talking about the X variables into a single vector, right? So now we have two columns, right? One column with the 30 variables and the target, which is whether it's 0 or 1, if it's benign or malignant. So again, this is the main difference to what you have done in the past. So remember, in most of the cases, it's not that you have to pick like pandas of Spark. Spark is mainly when you're facing a big data scenario with distributed data, across multiple machines. In that scenario is where you use this type of tools. Okay, so we train our model. We split data. Here we have logistic regression, and you can evaluate the model to get accuracies using same idea with the evaluator. So you can get predictions. Let's check the accuracy. It's high in this case, like 0.96. Of course, you will need to look the recalls, precisions if you want. And here you have the confusion matrix to perform all the analysis that is required in a classification scenario. And the last example is for clustering. So same idea, we have multiple algorithms available. The K-means, which is quite popular. And there are other alternatives, bisecting K-means, Gaussian mixture, LDA. Now, since this is unsupervised learning, remember that our data is not labeled. So we don't have a Y variable. So in this case, this is a Y problem, and we want to find patterns, right? We want to be able to cluster or group our observations. So this is the original data set. And now we have a single column. Remember that in the previous two problems, we had we had two columns, one for the features and the other one for the Y variable, for the label. But in the clustering, there is only a single feature. There is a single column with the features. There is no label. So here we have a vector with the 3 variables for each observation. And then you can perform the k-means. If you look at this code, it looks like scikit-learn, right? It's like if you don't know what is before, but again, this is a Spark ML. Okay, so we fit, right, the model with the data, and then we can start performing some clustering profiling just to understand, what are the mean values of each cluster for the different variables, and try to find some patterns. So here we find the cluster centers, and this is the predictions. It's the profiling. I'm sorry, cluster statistics. So we have the labels like group 0, group 1, and group 3. Three groups here. Number of observations in each group. It looks balanced. And then we have the three variables, the mean values inside each cluster. Right? So now you can start performing some comparison and describing the scenario, of course, depending of the context of your problem. So as you can notice, Spark is very useful. It's intuitive because it looks similar to what you have done in the past. It's not that learning something like really new from scratch compared to MapReduce, because the MapReduce approach requires way more coding and it's less standard. It's an older package, of course. So these are some of the like a comparison between scikit-learn and Spark. So scikit-learn is mainly designed for, typically X is a matrix, right? And the Y is a vector. It's an array with only one dimension. In the Spark, we have a Spark data frame, and we need to have two variables or two columns in the supervised scenario and a single column in the unsupervised scenario. So the key difference, scikit-learn is designed for a single machine, right? So everything is stored and processed in a single machine, while Spark it works when you have the distributed scenarios where your data is stored in different nodes in a cluster. It can also be processed in different nodes in the cluster, right? So scale limits in the case of scikit-learn, when you reach the 10 million, in some cases less than that. It will depend, of course, of your machine. But in the case of Spark ML, you can handle like billions of rows. So the parallelisms in scikit-learn, you can have some parallelisms. It's important to mention that when you have multiple cores, there is a njobs parameter that you can use to like activate the cores in your computer, but it's not designed to work like in different machines at the same time. Spark, on the other hand, that's the main idea. It was designed for that. Okay, I'm gonna stop the video for now. I'll see you in our next lecture.